Hello everyone, this is Charlie from the Bloomingdale Public Library, and today we will be discussing how to create our own classes and objects in Ruby. Now this is a massive subject, so for this video we're just going to focus on the basics. Here's specifically what we'll cover. We'll start off with a brief overview of object-oriented programming, terms, and concepts. If you're already familiar with these, you can feel free to skip past the PowerPoint slides. After that, we're going to create the most basic class and learn how to create an instance of that class. And then from there, we're going to learn to add some functionality to our class by getting into instance variables and methods. We're going to focus on a couple specific methods, namely the initialize method and getter and setter methods. After that, we'll take a brief look at class variables and methods, which are used a lot less frequently. And then we're going to finish up by developing a better understanding of references to objects. We're going to look at the specific examples of copying a custom object and checking the equivalency of custom objects. And by custom objects, I mean objects from classes that we create. Okay, so we're going to be covering a lot of terminology as we go along, but I'd like to start off with classes and objects. An object is just an instance of a class, or you can say it's a bit of data that's typed by its class. To give an example, when you say x equals 5, x would be an instance of the integer class, or you can say x is an object of type integer. So you can pretty much use the words instance and object interchangeably, and I probably will over the course of this video. A class is a blueprint for an object, which describes its states and behaviors, or basically what it is and what it does. For a bit more context, a state is the collection of values for an object's variables. So if you were to have a person object, and some of its variables might be like name and occupation and height, and we'll say those are worth like Joe, engineer, 6 feet, that collection of variables and those values would describe the state of that object. The behavior of an object is basically the collection of the methods associated with that class. A method is programming code that does things with data. Methods are like functions or procedures in other languages, except they're always associated with a class. And in Ruby, an object's variables can only be accessed through methods of its class. So you cannot access them directly, and that is part of the object-oriented programming paradigm, which we'll discuss next. Just one more slide I felt compelled to include before we start looking at some code. And this slide is a brief overview of the basic concepts of object-oriented programming, or basically the reasons we use classes and objects. Object-oriented programming is a programming model that structures its data and procedures around the use of objects. And you can compare this with procedural programming, which instead structures its code around just the use of procedures, also known as routines and subroutines. And both these models have their strengths and weaknesses. Just for a quick example, object-oriented programming is better for addressing real-world problems and much easier to code in, where procedural programming is much better for communicating with and programming machines, since all code eventually gets broken down into procedural programming anyway. Some examples of object-oriented programming languages would include Ruby, Python, C++, C#, and Java, where some examples of procedural programming languages would include BASIC, Pascal, just regular C, and assembly. The design goals of object-oriented programming are abstraction, encapsulation, inheritance, and polymorphism. Abstraction is what allows us to look at data and logic at a higher programming level, hiding lower-level implementation in the background. In other words, we can talk about dogs and trees and cars instead of memory heaps, data registers, and things like pointer arithmetic. I've also included a little chain here. You see Ruby sits atop of many other programming languages. So Ruby gets interpreted into C, which gets interpreted to assembly, which gets interpreted into machine code, which gets interpreted into ones and zeros. So you see, even though we're working with an object-oriented programming language, it eventually breaks down into procedural programming languages. Next is encapsulation, which is basically a way of protecting data through restricting access through class methods. We'll talk a little bit about that later. Inheritance is what allows us to derive new classes from existing ones, among other things. And I'm actually going to do a video about inheritance in a month or two. And polymorphism is what allows a piece of data or code to serve multiple purposes. An example of that would be where we use the plus symbol to both add integers together to give us a total, and we use it to concatenate one string to another. So that plus symbol is doing double duty, and that specifically is called operator overloading. Time to start coding. If you need help installing Ruby or getting your setup to what I have here on the screen, what you can do is find the video titled Introduction to Ruby elsewhere on our channel, and that will get you caught up. With that said, let's go ahead and create a class. To do that, all you do is type the word class in all lowercase, followed by a space, and then the name of your class. The name of your class needs to start with a capital letter, but other than that, it can just be alphanumeric. By convention, you only capitalize the first letter of each word with no underscores in between. So Robot Mama with a capital R, capital M, and no underscore, 1, 2, 3, would be considered a valid and conventional class name. With that said, we're just going to stick with robot for now. At the end of your class, you just type out the word end in all lowercase, and voila, we have a full-fledged class, albeit it doesn't have any variables or methods, so it really isn't good for much. Nonetheless, it is a complete class. If we wanted to create an instance of this class, what we would do is type the name of the class, followed by a period, and the word new in lowercase. Save it, run it, and sure enough, it runs without error, albeit it does not do much. So in order to get our class to be worth anything, we need to give it some variables and methods. But even before we do that, while we did create a new robot object, there is absolutely no way to do anything with it, even if our class did have methods and variables, and that's because we have no way to reference it. So our object is just sitting around somewhere in memory with no way to fetch it. And the way we fix that is by assigning this new robot object to a variable. I'm not feeling very creative right now, so we're just going to name it var1. And there we go. So what this does is it creates a reference to our robot object. So var1 here is not itself a robot object. It's just a reference to a robot object. And I know that's kind of a difficult concept to grasp when you're first getting into object-oriented programming, but I'll talk about it a little bit more at the end of the video. For now, let's focus on making our robot class a little bit more useful. There's a couple of things we can do to make this class more interesting, and the first thing that comes to mind is to include some instance variables. Instance variables hold data specific to a single instance of a class. For example, if you were to have a car class, you'd probably include instance variables for the make, model, color, year, etc. Now I want to keep this robot class pretty simple, so robots are going to get a name and a power level. To create an instance variable, what you do is start on a new line, and instance variables start with the @ symbol, followed by a lowercase letter, and then the rest of the name can be alphanumeric, whatever you like, but by convention, you keep it in lowercase, and if you have more than one word, you separate it with an underscore. So there would be name, and then for power level, we separate the words with an underscore. And there you go. Now, when you just list your variables at the top of a class or the top of your code, you are said to be declaring your variables, which if you come from a stricter programming language, that probably makes sense and you've done it before. But in Ruby, it really doesn't make much sense, although it won't give you an error. At the same time, you might be inclined to declare a default value, something like that. However, that won't give you an error either, but it's kind of pointless because anytime you create a new instance of your class, all the instance variables are going to be set to nil unless you declare some default values in a different way, which we'll cover in just a bit. In the meantime, you might recall if we're going to do anything with an instance variable, you're going to need some methods in order to interact with them. So that is what we're going to do next. Let's create some instance methods to interact with our instance variables. An instance method is just a method that acts on a single instance of a class. And to create one, you start a new line in your class and start off with the letters DEF, lowercase, followed by a space, and then the name of your instance method. And it follows the same conventions as the instance variables without the @ symbol. So we're going to create two instance methods, one to set the variables and another to print the variables. So we'll name this first one set underscore vars. And then to end your method out, just type the word end. I'm going to space this out a bit. So these two lines right here are a fully functioning instance method. To call the instance method, you start off with a reference to an object. So we're going to use this var1 here, followed by a period, and then the name of the instance method, which is set underscore vars. Save it and run it. And it runs just fine. Of course, it doesn't do anything because we're not printing anything to the display. Let's go ahead and fill this method out and then create another method to print the fruits of our labors. So we'll go ahead and set the name variable to Joe. And then we'll set the @power level variable to, say, 100. All right, to print this out, we're going to declare another instance method. Start out with DEF space, and we'll call this one print underscore vars. And this is just going to be a simple puts command. So we'll do name, colon, then for formatting, we're going to do \t. That is the escape character for tabs. And then we'll put the name variable. Follow that up with a new line character. And then we'll do power level. Another tab character. And the power level. There we go. So we already called the setVars instance method. Now we'll go ahead and call the printVars method on that same object. And we'll see if I have any typos. I'm going to save that, run it, and sure enough, we've got name colon, and the name is Joe, power level colon, and then the power level that we set it to in printVars. Perfect. Okay, so our class is up and running, and though it was never meant to be that robust, it would still be nice to be able to name our robots something other than Joe. We can do that by adding some versatility to the setVars method. We're going to do that by allowing the method to accept arguments, or some people say parameters. We do this by adding some parentheses after the name of the method, and then inside the parentheses we'll list the arguments that we want to accept. In this case, we want a name and a power level. And you can actually name these whatever you like. I just think it makes sense to name the arguments after the values that we're going to provide. There we go. And now that we're accepting these arguments, we can go ahead and change out these provided values to the argument names. So at name will be set to the name argument, and at power level will be set to the power level argument. There we go. Now, if your method is expecting arguments, you need to provide arguments in the method call. If you don't, you get an error that says your method is expecting some arguments. So let's go ahead and do that. We'll name the robot Jane and give her a power level of 101. Save it, run it, and there we go. Now we can use the method call to name the robot whatever we like and give it whatever power level. Cool. We can go a step further with our method by providing default arguments, and this will make the argument optional. So what we do is we come up here to our list of arguments and we'll assign them a value. So name, we'll assign default, and power level, we'll assign 0. So I'm going to go ahead and save it and run it again. And when you do that, you see we still get Jane at a power level of 101 because provided arguments will override the defaults. If we were to pull these values out, save it and run it, you see now we get the default values that we provided. Cool. Another thing we can do is make some of the arguments required and others optional. If you do this, make sure to make the required arguments first and the optional requirements second. Otherwise, you're going to get some screwy action with your values, and I can show you that. So let's go ahead. We'll make the name required, and you make an argument required by not providing a default value. So I'm going to save this, run it. You see we get an error because we are expecting an argument. So we'll go ahead and throw Jane in there. Save and run. And sure enough, we get the name in there. So the name is Jane, but the power level is still using the default value of 0. Now, just for demonstration purposes, let's go ahead and make the required argument second. So name we'll set to default, if I can spell it. And I'm going to take away the power level default value. So now the power level is required, but we'll still make the method call with Jane. Save and run. And you see the name sticks with the default, but Jane is put into the argument without a default value because it's required. And this is not a desired behavior, but at the same time, it doesn't throw a error. So it's something you have to be on the lookout manually for. So that is all I wanted to cover as far as writing your own instance methods. Next, we're going to take a look at some special instance methods that you should be aware of. So let's talk about the initialize method. The initialize method is just like any other instance method, except it's called when you create a new object, or as they say in the programming world, when you instantiate a new object. Looking at our code here, where you see it says var1 equals robot.new, it's this robot.new that triggers Ruby to do some stuff in the background to create a new object, but it also triggers Ruby to go looking in our robot class for an initialize method, and it'll run that off of this .new. So let's go ahead and create an initialize method to see how that all goes. Before that, like I was saying before, you don't actually have to declare your variables in Ruby so long as you're using them somewhere else in the class. Just to demonstrate that, I'm going to save and run it. You see everything runs just fine. All right, so with that said and done, let's go ahead and create an initialize method. And again, it's just like any other instance method. You just got to call it initialize. And for starters, let's go ahead and just do a puts command with initialize in caps. And you end the method just like you would the others with the end keyword. Save and run. And as you see, before anything else happens, we have the capital word initialize there. So because the initialize method is run as you create the object, it makes it a good spot to initialize the values of your variables. So let's go ahead and do that instead. It's good practice to have an initialize method, even if it's just to set some placeholder values for your variables that should be replaced later in your code. That could be a good indicator if something isn't working right when you see your placeholder values when you don't expect them. So I'm going to go ahead and create some placeholder values here. Name will be XXXXX and the power level. Oops. We'll set to negative 99999. All right, we don't want to reset these variables before printing it, so we're going to go ahead and kill the set vars method call, save it, run it. And there you go. You see how we've initialized the values for our variables in the initialize method. And just like the other instance methods, you can go ahead and accept arguments as well, just to demonstrate that. We'll do it just like our set vars method, where we'll accept a name and a power level. And then we'll set the variables to the arguments. And this will make it so when you create a new robot object, you have to provide the arguments as well. And even though we're calling the initialize method, you attack the parentheses and the argument list after new, which is not very intuitive, but that is how it works. So we'll go ahead and name it Jane with 101. Save and run. And there you go. And you can go ahead and do the stuff with the optional and required arguments as well. Again, just like any other instance method, it's just that it's called off of creating a new object. Next up, we're going to talk about getter and setter methods. As I've already said before, the only way to interact with a class's variables is through its methods. However, getter and setter methods do a pretty good job at emulating direct access to those variables. So let's go ahead and have a look at that. We're going to start off by writing a getter method for the @name instance variable. So what we would do, start out with def, and then just name. So that is the name of our method. Inside the method, we have @name. After that, we just close it off with the end keyword. So this is a method called name that returns the value of the @name instance variable. Outside of the class, let's go ahead and see how that looks. I'm going to do a puts command, and we'll do var1.name. Save it, run it, and there you go. So with this getter method, we're able to kind of access the @name instance variable directly. All right, that's fine. Let's go ahead and have a look at a setter method. And this will let us change the value of that @name instance variable outside of the class. The setter method starts with def space, and again, we're going to do name without the @ symbol, but after that, we're going to do equals, and then we're going to accept an argument, and what you call it is up to you. I'm just going to call it value. And then the body of the method is @name equals the name of your argument, which again I've called value. Close it up with the end keyword. And then down here, let's go ahead and assign a new value to the @name instance variable with the setter method. So we're going to do var1 dot name equals, we'll say Jimmy. We'll save it, run it, and sure enough, we're able to change the value with the setter method. Again, kind of emulating direct access to these variables outside of the class. Cool. All right. If that wasn't simple enough, that's okay. Ruby has made it even simpler, and we'll have a look at that with the power level variable. So what we're going to start off here is with attr underscore, which I believe stands for attribute. If you recall, that's one of the many names that people use for variables inside of a class. And we're going to reader, colon, and then power level. No @ symbol. All right, out here, we'll go ahead and do a puts statement for var1 dot power level. Save and run. It works just fine. So this statement here is just a macro that spits out all of the code for a getter method for power level. As you might guess, there's also a method for the setter as well. So let's do attr underscore writer colon power level. Again, all this does is generate the code for the setter method with a macro. Down here, we'll go ahead and do var1 dot power level equals, we'll say 1. Why not? Save, run. Sure enough, we were able to change the value outside of the class with the help of the setter method, or rather the setter macro. All right, time for the grand finale. I'm going to overwrite both of these with a macro that replaces both the getter and the setter. And that goes something like attr underscore accessor colon power level. All right, let's see if the code still works. Save and run. There you go. So that's all there is to it. Again, we used a getter and a setter method for the @name instance variable, and then we demonstrated a couple macros for the getter, setter, and both using the @powerLevel instance variable. That's all there is to it. Thus far, we've worked with instance variables and instance methods to work on an individual instance of a class. Now we're going to take a very quick look at an example of using a class variable and a class method to act on the class as a whole. So as you can see, I cleared out our robot class. And that's because these robots aren't going to get names or power. They're just going to exist to be counted. And to do that, we're going to use a class variable called total. And for a class variable, you need to start with @symbol, @symbol. So 2 instead of just 1, total. And that would be a class variable. Unlike instance variables, you need to declare an initial value in order to use it. So for our total, we're going to start it off at 0. It should make sense. And there you go. We have declared a class variable. All right, this class is going to have an initialize method. And all it's going to do is add to the total every time a new robot is created. So total plus equals 1. So again, every time a new robot is created, it's going to call the initialize method, and it's going to add 1 to that class variable called total. We're going to close that up with the end keyword. And now to see what our total is, we're going to declare a class method. And to do that, start off just like before, def space, and now we're going to declare this method on its self. So it goes self dot, we'll say print total. And in here, we're just going to have a puts statement, total, colon, tab, and then the class total variable. That's it. So again, we have a class variable for keeping a total of how many robots we create. And then we have a class method for printing out what that total is. Okay. Next, we have to create some robots to count. I'm just going to do robot.new. Because we're not doing anything with any of these robots, it's not necessary to assign them to a reference. We're just going to create them. I think that's 6. Okay. So now we've got our 6 robots. What we do to call a class method is we use the class name dot and then the name of the method. Okay. Let's go ahead and save it. Run it. And sure enough, we've got 6 robots. So again, just a very quick overview. Everything works pretty much the same. Conceptually, it might be kind of hard to grasp the idea of class variables and class methods being shared amongst instances of classes. But if you want to do some more reading on that, I strongly encourage you to do so. You'll also see how a lot of the Ruby experts tend to try to steer people away from using too many class variables and class methods. And that's another reason I just kind of skimmed over them here. If you wanted some homework, you can try creating a getter and setter method for a class variable. You can do it. The macros do not work, but they're still pretty short methods to write. So go ahead and give that a try. One last topic I'd like to cover before we call it a day, and that's just a brief overview of what a reference to an object is and some trip-ups that people just getting started with object-oriented programming hit, namely copying objects, copying references, and testing for object equality. So we're going to go about this in 3 different ways just to try to hammer this home. We're going to start off with the slide here, then we'll move on to some code, and lastly we'll look at a drawing I made in Paint. So with that said, let's go ahead and take a look at this slide here. So when you're creating a new object and then assign it to a variable, the value stored in that variable is an address of a new object. The variable is said to be a reference to that new object. It does not store the object itself. For example, when you set var1 equal to a new widget, var1 is now a reference to a widget, but itself is not a widget. So var1 is a reference to a new widget object, but itself is not a widget. If you assign the reference of an object to another variable, you are only making a copy of the address of the object. You are not creating a second object. For example, if you set var2 equal to var1, var2 now holds the same address of the same widget. So you did not create a copy, you just copied the reference, and you still are only pointing at one object. To copy an object, you actually need to create a new instance of its class and then copy each value of each instance variable individually. So if you're not doing a widget.new or robot.new or whatever, you're not creating a second object. So when you're comparing two objects for equality, you must look at each value of the instance variable of both objects, not the values stored in the references. The references of two different objects will never be equal. So if we go back up to the example here, if you knew var2 and var1 actually were different objects and you were testing them for equality, even if all of their values are the same, var2 is not going to equal var1 because they're going to have different addresses to these objects that are otherwise the same. So that is my attempt in words to drive that home. Next, let's look at some code. Okay, so I've got a version of the robot class that we were working on earlier, with the exception of an extra class method that I threw in here for copying a robot object. Before we look at that, let's look at the code beneath the class here. We go ahead and set the reference robot1 to good old Joe with the power level of 100. Then down here, we set robot2 equal to robot1. So robot2 now holds a reference to the same object as robot1. So robot2 also equals Joe at power level 100. So let's say we change the name of robot2 to Zach. Let's go ahead and run that. Sure enough, we changed robot1's name to Zach as well because they're pointing at the same thing. I did a little bit extra here in that I'm also showing the object ID, and you can see the object ID of both of these objects are the same. It's because they're the same object. And you do that with this code right here. You just do the object, then dot object underscore ID. So if we actually wanted to make a copy, what we would do is something like this. So robot2 equals robot.copy, and then we're passing robot1 as an argument. So then we come up here, and you see we actually create a new robot, and then set the names equal and the power levels equal, and then return that copy. So now that we have a full-fledged copy, and change the name of the copy, the names should be different, and the IDs should be different. Let's have a look. Sure enough. So we actually made a full-fledged copy and changed the name of that copy without changing the name of the original. And we did that because we're now working with two different objects, and we can tell that because the object IDs are different. Okay, so that was my effort to explain that through code. Let's have a look at my beautiful paint picture. Ta-da! All right. Up here, we see we're setting the references equal to each other, which means they have the same address of the same object pointed at right here. Over on the other side, you see we created a second object and set the individual instance variables equal to each other, and that is how we get two separate references pointing to two separate objects, but at the same time these objects hold the same values. Now there are reasons why you'd want to set references equal to each other versus creating full-fledged copies of objects for doing stuff like swapping or things like that, but that's usually not what a beginner intends to do. Usually that happens by accident. So there you go. 3 different efforts to explain what happens when you copy references and how you should go about copying objects. And on that note, we're going to call it a day. Hopefully you learned something. Hopefully I piqued your interest. Hopefully you're going to get out there and start writing some Ruby programs. And after that, you have a wonderful day. Thanks for viewing.